is made. Now its schematic diagram. Again, it is totally same as SR latch, but only difference is the clock pulse. So here again I am using, or I am making it with the NAND gate only for your convenience. So as you can see, I have drawn here the clock pulse firstly. If clock signal will be given to the circuit, then only the whole process will be start. Otherwise, it will be no change. So whensoever clock will be given, and depends upon the situation, if it is 1, S is equal to 1, then there will be set condition. If R is equal to 1, then it will be reset condition. Otherwise all cases are same here also. Actually this is pulse transition detector. Pulse transition detector is used here, which counted the pulse, or which you can say which generating the pulses also, and after generating or detecting the pulse only the whole system will work. Likewise our SR flip-flop is also done. Now it's D flip-flop. In the D flip-flop, if D is equal to high, then it is a set condition. If D is equal to low, then it is reset condition. D means data, one input data. Q will follow D at clock edge. So what does it means? Ki Q totally depends upon the value of D, and with the D we'll apply clock pulses here. To change the SR flip-flop to the D flip-flop, only one thing is used here, that is NOT gate. Otherwise our whole system is totally same with the D latch. Only difference is the clock pulse, and inverter gates we have already used in the case of D latches also. Firstly need to make it truth table D, clock pulse and Q, and there are comments. Situation can be 0 or 1, as it is only one input, that's why it can be either 0 or 1. In the case of 0 and 1, and when clock pulse is applied, so if it is 0, then which means it is reset, and if it is 1, then which means it is set condition. Now its schematic diagram is So as you can see, only difference is there, inverter, otherwise it is totally same as the SR. Clock pulse is given and inverter gate is used here, otherwise it output also, first gate output depends upon the value of second gate, and second gate output depends upon the value of first gate input, otherwise it is totally same as SR flip-flop. Now next is JK flip-flop. The name JK is Jack Kilby, which is a scientist name who invented this flip-flop, otherwise it is also do the same function as SR flip-flop or other flip-flop has done. Jack Kilby flip-flop. So in the JK flip-flop, first main thing which need to be considered or which need to be remembered is there is no invalid state. In the case of D flip-flop also there was no invalid state, but there was only one input there. But in the case of a JK flip-flop there is no invalid state. There is a state which is toggling the condition. So here I am explaining you what is toggle or what is toggling. Firstly, if the value of J is equal to high, then which means it is set condition, and if J is high then which means K is low. First case is this, and second case, if the value of K is equal to high then it is reset condition, and whensoever K is high then which means J will be low. And if third case is both J and K is low, which means both inputs are 0, then then there will be no change occurs. In the fourth or most important case, when J or K both will be high or both will be equal to 1, then there is no invalid state here. There is a state which is called toggling the condition. Now what is toggle and what is this situation? This toggle and toggling condition will explain in the truth table and its schematic diagram. So let's start with the JK truth table and its schematic diagram. So firstly, J and K. The whole concept will be understood by the you after making its schematic diagram, because what its diagram says, again with the help of NAND gates, output is Q and Q dash. Now what we were doing earlier, first gate input depend upon the output of second, same second gate input depends upon the value of first gate output. So after this is totally same as the SR latch, but what's the difference in JK? There's only one difference, which is toggling state here. And how this toggling state occur? This state occurs with the feedback only. Now the last gate output will totally depend upon the input of second gate, and second gate output totally depends upon the first gate input. What does it mean? It means whensoever its output will come, then its out, let's suppose its output is 1. Whensoever its output will come, then only it goes to the input of the J. And when its output will come, then only it depends. Then only it comes with the K first gate. So here also clock pulse will be there, or pulse transition detector, which detects the pulses J and K. Now clock pulse is here. Clock pulse is high, 0 0 0 1 1 0 and 1 1. If it is 0 0, then which means no change is there, Q will become the Q. And if it is 0 1, 0 1, which means J 0, I've told you earlier, whensoever J is high, then it is set, and when J is low, which means K is high, then it is reset state, and reset means 0. Situation is reset. 1 0 is set 1. 1 1 is toggling the condition. Toggle means J is equal to 1 and K is equal to 1. This situation is also known as race around condition. Race around condition. So you can say that it is a drawback also in the case of JK flip-flop, because both input can't be 1. J1, K1 can't occur in the same time. So toggling occur in the case of JK flip-flop. This totally happens just because the whole output depends upon the first gate and the second gate. Here the feedback is considered, and feedback considered in the reverse side, not with the same side but in the reverse side. So that's why toggling occur here, which means J is equal to 1 and K is equal to 1. Now the last flip-flop is T flip-flop. T flip-flop. T means toggle or toggling flip-flop. So T flip-flop single input version of JK flip-flop formed by combining JK inputs. So what does it means? T flip-flop is totally same as the D made with the SR but with the help of inverter. But in the case of T flip-flop, we will not use any inverter. We just combine the JK flip-flop and make the T flip-flop. So how we'll do this? T flip-flop is like T, only one input is there, otherwise it is totally same as JK, Q, Q dash. Clock pulse will be given, or pulse transition detector is here. Again, output totally depend upon its input, and its output totally depends upon the first one input. So as you can see here, it is totally same as the JK flip-flop. Only difference is it has only one input. JK flip-flop has two input, it has only one input. Likewise the D flip-flop, data flip-flop, but in a data flip-flop, I am repeating, in data flip-flop we used inverter gate, but here we are not using inverter gate, and we make it with the JK flip-flop, not with the by combining the SR, but by combining the JK flip-flop. So in T flip-flop, it can either 0 or 1. Clock is high, and Q output and commence. So if it is Q, then it will not change, no change, it will become as it is. But if it is 1, then it is toggling the state, toggle condition. You can write it here as Q dash. So with this, our whole flip-flop and latches topic will be covered. I hope you can very well understand the basic of sequential and combinational circuit, and the main difference between combinational and sequential circuit, what is latch, what is flip-flop, what are the types of latches, and what are the types of flip-flops. And in my next lecture we'll do the master slave. Master slave is using in the case of flip-flop and in the case of JK flip-flop, and the problem which arises in JK flip-flop we overcome in the case of we overcome this whole problem by studying the master slave flip-flop. So with this, our whole latches and flip-flop topic is covered. Thank you so much.